Study shows the Sahara Desert swung between lush and desert conditions every 20,000 years, in sync with monsoon activity. Jennifer Chu, Massachusetts Institute of Technology, writes this article on phys.org. That's a surprise. In a new analysis of African dust reveals the Sahara swung between green and desert conditions every 20,000 years, in sync with changes in the Earth's tilt. This is a study, a research by Massachusetts Institute of Technology. In other words, the Earth's tilt changed what Sahara conditions were like. The Sahara Desert is one of the harshest, most inhospitable places on the planet, covering much of North Africa and some 3.6 million square miles of rock and windswept dunes, but it was not always so desolate and parched. Primitive rock paintings and fossils excavated from the region suggest that the Sahara was once a relatively verdant oasis where human settlements and the diversity of plants and animals thrived. Now researchers at MIT have analyzed dust deposits off the coast of West Africa over the last 240,000 years, and they found that the Sahara and North Africa in general has swung between wet and dry climates every 20,000 years. They say that this climatic pendulum is mainly driven by changes to the Earth's axis as the planet orbits the sun, which in turn affects the distribution of sunlight between seasons every 20,000 years. The Earth swings from more sunlight in summer to less and back again. For North Africa, it's likely that when the Earth is tilted to receive a maximum summer sunlight with each orbit around the sun, this increased solar flux intensifies the region's monsoon activity, which in turn makes for a wetter, greener Sahara. When the planet's axis swings towards an angle that reduces the amount of incoming summer sunlight, monsoon activity weakens, producing a drier climate similar to what we see today. Quote, our results suggest the story of North Africa climate is dominantly this 20,000-year beat going back and forth between a green and dry Sahara, says David McGee, the associate professor in MIT's Department of Earth, Atmospheric and Planetary Sciences. He says, we feel this is a useful time series to examine in order to understand the history of the Sahara Desert and what times could have been good for humans to settle in the Sahara Desert and cross it to disperse out of Africa versus times that would be inhospitable like today. McGee and his colleagues have published their results today in Science Advances. There's a puzzling pattern here. Each year, winds from the northeast sweep up hundreds of miles of tons of Sahara dust, depositing much of this sediment into the Atlantic Ocean off the coast of West Africa. Layers of this dust build up over hundreds of thousands of years and can serve as a geological chronicle of North Africa's climate history. Layers thick with dust may indicate arid periods, whereas those containing less dust may signal wetter eras. And scientists have analyzed sediment cores dug up from the ocean bottom off the coast of West Africa in order to get clues to the Sahara's climate history. The cores contain layers of ancient sediment deposited over millions of years, and each layer contains traces of Saharan dust, as well as the remains of life forms, such as the tiny shells of plankton. Past analyses of these sediment cores have unearthed a puzzling pattern. It appears that the Sahara shifts between wet and dry periods every 100,000 years, a geological beat that scientists have linked to the Earth's ice age cycles, which seem to also come and go every 100,000 years. Layers with a larger fraction of dust seem to coincide with periods when the Earth is covered in ice, whereas less dusty layers appear during intergalactic glacial periods, such as today, when the ice has largely receded. But McGee says this interpretation of the sediment cores chafes against climate models which show that Saharan climate should be driven by the region's monsoon season, the strength of which is determined by the tilt of the Earth's axis and the amount of sunlight that can fuel monsoons in the summer. McGee says, we were puzzled by the fact that this 20,000-year beat of local summer insolation seems like it should be the dominant thing controlling monsoon strength, and yet in dust records you see ice age cycles of 100,000 years, end quote. So there are beats in the sync. They synchronize to the patterns of drought and wetness. To get to the bottom of this contradiction, the researchers used their own techniques to analyze a sediment core obtained off the coast of West Africa by colleagues from the University of Bordeaux, which was drilling only a few kilometers from cores in which others had previously identified as a 100,000-year pattern. The researchers, led by first author Charlotte Sconesi, a former MIT postdoctorate and now a professor at Paris Sud University, examined layers of sediment deposited over the last 240,000 years. They analyzed each layer for traces of dust and measured the concentration of a rare isotope of thorium to determine how rapidly dust was accumulating on the sea floor. Thorium is produced at a constant rate in the ocean by very small amounts of radioactive uranium dissolved in seawater, and it quickly attaches itself to sinking sediments. As a result, scientists can use the concentration of thorium in the sediments to determine how quickly dust and other sediments were accumulating on the seafloor in the past. During times of slow accumulation, thorium is more concentrated, while at times of rapid accumulation, thorium is diluted. The patterns that emerge was very different from what others had found in the same sediment cores. Quote, "What we found was that some of the peaks of dust in the cores were due to increases in the dust positions in the ocean, but other peaks were simply because of carbonate dissolution and the fact that during ice ages in this region of the ocean was more acidic and corrosive to calcium carbonate. It might look like there's more dust deposited in the ocean when really there isn't," McGee says. Once the researchers removed this confounding effect, they found that what emerged was primarily a new beat, quote unquote, a new rhythm in which the Sahara vacillated between wet and dry climates every 20,000 years in sync with the region's monsoon activity and the periodic tilting of the earth. Quote, "We can now produce a record that sees through the biases of these older records, and so doing tells us a different story. We've assumed that the ice ages have been the key thing in making the Sahara dry versus wet, and now we show that it's primarily these cyclic changes in Earth's orbit that have driven wet versus dry periods. It seems like such an impenetrable, inhospitable landscape, and yet it's come and gone many times and shifted between grasslands and a much wetter environment and back to dry climates, even over the last 250,000 years," McGee says. This journal references Science Advances provided by Massachusetts Institute of Technology, and it's on phys.org. Now, this means that because of the desert conditions in Sahara, people were forced to move. The prehistoric people were affected by the change in climate. It was a warning alarm dog. Beneficial climate change allowed modern humans to emigrate out of Africa and spread around the globe. This is what a new PBS documentary, First Peoples, stated, but it failed to mention that in that era, the designated good times was actually temperatures that were several degrees warmer than they are today. A critical moment in human history, movement of prehistoric peoples were affected by the climate, which fluctuated over thousands of years. In bad times, Sahara was, as we said, an uncrossable barrier, but in good times, when the climate was wet, the desert disappeared. Any adaptation that emerged in one part of Africa could spread to other parts of the continent. That would have been a warm period, not just because the PBS warming alarm dog would have barked if it was a bad or dry period that was warmer, but because a warmer planet with more evaporation and more rain should on average be wetter. Then there is the known effect that the most recent period of global warming had in North Africa, seen in the green of the Sahel between 1982 and 2003. It was the EMIN. Quick search for wet Sahara, modern human migration, turns up this form of popular archaeology. Study confirms ancient river systems in Sahara 100,000 years ago. Evidence from past research suggested that sometime during the period between 130 and 100,000 years ago, the Sahara Desert region we know today was wetter, featuring rivers and lakes, providing an environment that many scientists theorize permitted the earliest modern humans to migrate northward from points southward in Africa towards the Mediterranean coastline and areas eastward into the Levant, which is, of course, Syria, Jordan, and Lebanon today. This is also from What's Up With That. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.